Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong, AWS, and Aqua Security. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of the presentation or you'd just like to share it with a friend, the on-demand will be made available after the webinar concludes. I'd like to direct your attention to the right side of your screen, where you'll see a couple options. The first one being our chat tab. And this is where we want you to engage with one another, where we want you to engage with us. Let us know where you're calling in from and give us any kind of feedback that you want to throughout today's presentation. And then there's also the chat tab, or the chat tab and the Q&A tab, where we want you to send in those questions. Finally, at the end of today's webinar, we'll have a giveaway for $25 Amazon gift cards. So stick around to see if you're one of our winners. But on to our presentation today. Our topic is what's next for DevSecOps, shift right for runtime protection. And I'm joined today by Jake Milosh, Solution Architect at Aqua Security, Steve Copeland, Director of Product Marketing and Strategic Alliances at Aqua Security, and Young Jung, Partner Solutions Architect with Amazon Web Services. And at this point in time, it's my pleasure to turn the floor over to Steve to get us started. Thank you so much for being here with us.
Thanks so much, Cody. Thanks everyone for joining us today. Apologies in advance. Just had some technical issues as we were kind of moving to the live portion. So as I say, apologies in advance, and if I drop off, Jake has graciously offered to step in. So just quickly, by way of brief introduction, my name is Steve Copeland. As Cody mentioned, I'm the Director of Strategic Alliances, Product Marketing here at Aqua. I'll be leading things off, and I'll hand over to Young. We'll talk more about the AWS shared responsibility model and how runtime protection fits in with a range of AWS services. And then we'll make way for Jake, who will go through a demo. And then we'll all reconvene for the Q&A portion. We're hoping to kind of hold questions until the Q&A portion. But if there's a question arises that's kind of relevant to the discussion at hand, we'll try and answer it appropriately. So kind of just to set the stage, what the agenda is, we'll start off with where does runtime security and shifting right fit into the cloud native framework? Why is shifting left and shifting right important to manage cloud native risk? What does shifting right and runtime protection actually involve? How does runtime protection fit into the shared responsibility model? How can cloud service provider tools reinforce runtime protection? And then we'll be weaving throughout that how an integrated shift right approach can help compliance initiatives. And then, as I mentioned, we'll be moving into the demo, followed by the Q&A. In terms of what cloud native is, I'm assuming that many of you are kind of familiar with the concept. I would just say that what we've seen at Aqua is that more workloads are being born in the cloud. We're seeing dev tests move into workloads move into production. We're seeing more customers move from VMs to containers. And we're definitely seeing much more adoption of managed Kubernetes services. We're seeing adoption of containers as a service. We're seeing adoption of function as a service. So, Fargate and Lambda is certainly, adoption of Fargate and Lambda is certainly trends that we see quite markedly in the market. So what is cloud native? Cloud native essentially is a phase process with two major phases: the build phase and the run phase, with kind of deployment acting as the hinge between two of these. Essentially, there are plenty of benefits, and this is why there's been such widespread adoption and ongoing maturity in the adoption of cloud native. Cloud native allows for velocity in the development process, automation in the deployment, and run phase. Allows for kind of reuse of components, repeatability, and improves cost. So what are the risks involved? Just as with any adoption of new technology, new risks emerge. Slide, hopefully you can see it on my end. I'm having difficulty resolving it. But the kind of same principles hold when looking at a cloud native. You really want to address the attack surface. But there are kind of new risks that present themselves with cloud native. One is as we hear more and more about, is supply chain security, because of the way the developers use third-party and open source components in the build phase. And then in the runtime, there's also an issue in terms of what we refer to as a blast radius, where if you compromise a single container, you might be able to affect east-west traffic or north-south traffic, where you'd actually be able to compromise the container, the host itself. So moving on, these are the kind of the risks. What is the kind of the practical reality in terms of how the kind of attacker economy, so to speak, is evolving to exploit those risks? I think the kind of the point to bear in mind is that ultimately what the attacker wants to do is gain access, is gain privilege access, and then execute an exploit or some kind of attack in the runtime environment. So often the kind of, because of the with the 0-day exploit or kind of a potential misconfiguration that somebody's missed in the build phase, the attack will manifest in runtime. And I think a kind of important thing to note is as we've seen kind of a very rapid evolution of cloud native specific attacks. Clearly there's kind of evolved from more opportunistic approaches, but there's definitely been, and I'll kind of talk a little bit more in the context of Log4j, that attackers are moving much more quickly and have much more sophisticated processes or flows in order to execute an attack. So just bear with me as the next slide loads, and I think Jake or Yang, do you mind? Okay, so it looks at my end again. Apologies everyone for the technical issues.
Yes, Steve, so I can jump in for you. So when we're looking at the security concerns as they're well-founded, we can look at a couple of statistics here about some of those recent attacks and just kind of put into light what the average time for a compromised resource to be able to take action or be able to get taken advantage of, and that's 45 minutes. And so if you happen to be a dev or someone just trying to test something out to see how it's going to be configured or how the process is supposed to work, if you forget to be able to close that resource back down or happen to have some kind of misconfiguration that you didn't even intend to have, there's going to be 45 minutes later before that resource is going to be able to get accessed by someone that doesn't want necessarily, you don't want to necessarily have access to that. And then after that having issue being found, the time for that to be resolved is now 88 days. So there's a lot of time in between all of those actions that could be taking place, and we're seeing in the market and in the ecosystem, these are the average times that we're seeing those actual values come through. And of course, on the right side there's some of the big attacks that have just recently happened, and of course, Log4j being the most recent one, where 2021 wanted to make sure we didn't forget about it at the end of the year there. And just like that, we have the same kind of stats for that kind of attack as well. Steve, are you still seeing these slides, or you want me to keep going?
Yes, I think, thank you, Jake, for filling in. I think, yes, I mean, I think that Jake, mentioned Log4j. I don't think it's appropriate to generalize from Log4j, but I think we can certainly extrapolate about the evolution of the kind of the attacks that will be targeting cloud native. And there is a kind of, there's always a question of what is a real risk, what is a practical risk, and it certainly kind of illustrates that there is a very kind of robust set of attackers and tools out there and approaches that kind of range from remote code execution to botnets that are kind of focused on zero-day attacks. So the question is okay, so you're kind of faced with that kind of attack environment. What is the best way to tackle the risk, right? And I think, from Aqua's perspective, cloud native actually presents an opportunity to do security right. Shift left there's not necessarily, we're not proposing a kind of dichotomy and either or situation here. The shift left and shift right are really kind of critical to work together. I think what we've seen with shift left is that it's really important for security teams to understand or to communicate how security can be integrated into the DevOps workflow, whether it's looking at ISC security scanning, whether it's scanning code in CI/CD pipelines, whether it's kind of managing high risk vulnerabilities, but equally on the shift right side, there's also kind of challenge that we've seen where security teams who've kind of necessarily kind of dealt with more kind of traditional security concerns are kind of having to get up to speed fairly quickly and acquire domain expertise in cloud native. So what's really important in looking at this as an understanding kind of risk holistically is that there's a shared context around what needs to be done from a kind of cloud native security perspective, and also that there's some kind of feedback loop, and this is something that we'll kind of touch on when we look at the points of integration into AWS cloud security services. The point is that often if you do discover a kind of security issue or a zero-day attack in the runtime environment, you want to take that learning and loop it back into the way that the applications themselves are built, and identify if there's a kind of image or third-party component or an open source component that potentially is a kind of compromised container that an attacker has managed to slip into the build pipeline that needs to be remediated, and you need to understand which other applications are using that particular container and set out to remediate and fix as necessary. So kind of let's look at what actually is runtime protection. Again, it's taking a little time to resolve it at my end, but I think what you want to kind of do when you're approaching this topic is understand there's kind of two facets, right? One is you want to ensure that you're doing the right thing, and that comes in the form of assurance policies. And number two, you want to ensure that you stop doing the wrong thing, stop doing so where it's not going to be enormously disruptive to the application, because that's not only is it kind of ineffective, but it also kind of creates a knock-on effect in terms of the perception of how cloud security is implemented from a kind of broader enterprise perspective, because ultimately the intent is to kind of achieve those cloud native benefits. So how do we know it's the right thing? How do we know it's the wrong thing? Essentially, what you need to do is kind of encapsulate both those things into policies. So the kind of the most straightforward way to define a policy is to kind of move from compliance and look at security best practices. So we work quite closely with AWS on the infrastructure security side to look at things like AWS CIS benchmarks and the management and governance lens, which kind of help you understand what is the best setting configuration for your environment. And then moving towards the prevention policies, there's a number of dimensions here that you can kind of work off. Number one is looking at something that is known as container mutability, where you define what the originating image, and this is again kind of important to be looked at across the life cycle, If you understand what the originating image is, and then you start to see some changes in runtime, that's unlikely to be legitimate behavior unless it's kind of explicitly authorized. As we were saying earlier about remote code execution, is there a reverse shell session that's been initiated in runtime? That's probably something you want to stop. Is there, code that's being downloaded in runtime? That's probably something you want to stop as well. So the idea is we can kind of move to the next slide. Jake, if you want to, okay, so there we go, the workload protection controls. So what we've seen is organizations want to kind of start with, common sense, fairly, baseline set of policies and iterate over time, right? So blocking access to a running workload, blocking modification to a running workload, it's probably all kind of, good security practices that you want to have in place as you start to move through the cycle. File integrity monitoring is an example of a kind of compliance policy. It's specified under PCI DSS, and it's generally a kind of good security practice to make sure that you're monitoring changes and making sure those changes are appropriate. Allow or block inbound or outbound networks. Again, it's kind of important to the to reducing the blast radius. And then, a kind of emerging area that we're seeing is the use of eDPF to identify indicators of compromise. And then, because of the kind of the evolution of the attacks and the more zero-day attacks, focusing on cloud native architecture, it's really important to kind of look at the kernel level visibility and apply rules that are based on intelligence or detection intelligence for those cloud native attacks in order to identify indicators of compromises. So just double click for a moment on this idea of container immutability. What we at Aqua call drift prevention. It's really important or really helpful for stopping zero-day remote code execution attacks because unless something's explicitly authorized, you can with fairly high degree of confidence identify when there is an attack in place. And it's also important to kind of point out when we talk about gradient prevention, the need to maintain application uptime, application availability, that you're really stopping something that's outside of the legitimate behavior of the container. So the application itself is not affected. So just bear with me as I'm waiting for the slide to load, and that should be security best practices. So I think one of the important elements as we were talking about shift left and shift right is you want to reduce the potential, the likelihood of the security weaknesses that could lead to a runtime attack, and that's things like misconfigurations, things like embedded credentials, things like vulnerabilities that you can better address earlier on in the life cycle by moving to shift left. Again, kind of maintaining a robust set of policies about what needs to be done right. Enforce those policies. So if the image does not meet assurance definitions, if there are embedded credentials, if there are kind of environmental variables included in that image that don't conform to assurance policies, if it's a Kubernetes assurance policy that provides kind of access to the Kubernetes API without any kind of role-based controls around it, you want to stop that from being promoted. And the other element is looking at which workloads you're protecting, right? So What works for VM workload is not going to work for Fargate workload, is not going to work for a Lambda workload. And also you want to make sure that in order to avoid those blind spots, that deploying the runtime prevention controls is part of your provisioning process. And that's important to look at things like CloudFormation templates. And equally, if you kind of then, look at things from a kind of holistic perspective, you want to make sure that you're logging, reporting in order to facilitate incident response, forensics, and audits with integration into AWS Security Hub, CloudWatch, and CloudTrail. And with that, I'll hand it over to Yang to talk through the implications for the shared responsibility model and what those integrations can look like.
Thanks, Steve. Just to carry on the conversation here, we touched some base on shift right practice, where it sits, sort of the best practices around runtime protection, and I just want to paint a little picture around what this actually looks like as an implementation on AWS. So when it comes to security, we here at AWS sort of brings this idea of what we call the shared responsibility model, where the responsibility for security within the cloud is shared between AWS and the customer. And I'll show an illustration of this in the next slide. But essentially, what we're talking about here is the model relieves sort of the infrastructural burden. Think of it as the infrastructure of the VM that sits behind the host operating system, any virtualization layers, and even the physical security to the responsibility of AWS. And what the customers assume responsibility for is what essentially lives in the cloud. So when it comes to shift right practice, and particularly on runtime security, we're talking about, as you deploy your cloud native application, whether that's containerized or otherwise, we're talking about securing those applications, the configurations that come with it. So in that sense, you can kind of see where the customer responsibilities lie within shift right practice. So some of the things that you can think of are listed right there. And as I'll illustrate a little bit later, those things could shift either or depending on the service that you choose to deploy your applications with. But some of the responsibilities or some of the categories that you can think of here are things like AMIs or orchestrators in the case of Kubernetes upgrades, things like image security or image scanning, access management for your applications or for your clusters, security configurations, observability, which I think is one of the more rising areas of day two operations when it comes to your containerized workloads, and of course, secret management. So just to kind of put those ideas or that model into a more consumable diagram, here is what the shared responsibility models look like. So like I illustrated earlier, on the left, you can sort of see how we define in a short sentence or a short phrase of the customer who is responsible for the security in the cloud. So things like customer data, applications, platforms, access management of those platform or applications, or network and fire configuration. Whereas AWS is responsible for security of the cloud. So the underlying infrastructure, the hardware, the location of those hardware and the security of those hardware, and of course the basic operating system layers. The delineation here isn't exactly rigid in the middle. It really depends on what service you choose may differ a little bit. So For example, when we talked about one of the responsibilities being AMI or the orchestrator patching or the upgrades, if you think of a service like EKS, which is our managed Kubernetes service, you could assume, or you could, the responsibilities between AWS and the customer could shift slightly based on, let's say, what sort of node group management you end up choosing. Let's say if you as a customer is managing your worker nodes, obviously the control plane is all managed by AWS, and the patching that comes with it, and the core components like etcd and so on and so forth. But if we're speaking in terms of worker nodes, if you are leveraging something like Fargate, AWS will also assume the responsibility for the underlying instances that come with Fargate, which is the serverless option. Whereas if you are managing your worker nodes by yourself or self-managed, of course, it falls on you as a customer to manage the patching of your Kubernetes. So I think a key takeaway here when it comes to shared responsibility model is just to be aware of where your application sits, or depending on what service you end up leveraging, where that line is drawn, and where you as a customer is expected to implement some of the controls in place to ensure that your application or the environment is secure. So with that said, how can we put those in place, or how can you as a customer put some of those practice in place? And I'll be talking about this in two parts. So first, we'll sort of go through some of the native controls that's available on AWS. And two, how do we leverage partners like Aqua, who brings additional, I think, and complementary configurations or controls or functionalities, whatever you want to call it, that supplements to put this holistic approach to a more complete package. So in terms of native controls, these are some of the things that you would expect. And obviously, this is not a complete list. There are other things in considerations as well. But some of the things that you could think of are leveraging something like key management service or KMS for your encryption strategy. Other things like using config or the fire manager, which is our service to ensure that you can automate your configuration of your security groups or other networking configurations. Obviously, one of the more prominent things that we usually talk about is access management. How do you grant different users varying levels of access to your resources or your applications? And when we say access management, we always choose roles over users. What that means is we want to create roles that gives principle of least privilege, or the permissions necessary for somebody who's assuming the role to do their task or their scope of work. And in terms of more a containerized approach here is thinking about monitoring and securing your image. And the two things that come to mind are leveraging something like Container Insights, which is which is focused on containerized metrics and diagnostics, information that you can pull from your container workloads and help you sort of dashboard it or visualize it on CloudWatch, which then will help you isolate some of the issues that may arise and help you resolve them. And when it comes to image security, ECR, or our container repository, provides some basic image scanning as far as an OS level sort of scanning, with an enhanced scanning with our one of our other vulnerability service, Amazon Inspector. And with a lot of these services that come with AWS, we try to make it easier for our customers to get a single pane of glass when it comes to vulnerabilities or security configurations and sort of meeting the compliance that's required to run your workload. So with that, we have our service called Security Hub, which is a security posture management where you can have a single place to run your security best practices. You can aggregate alerts and enable automated remediation. And this is a place where not only we have AWS native services that some of which talked about, things like Inspector or Firewall Manager, but also our partners' solutions. So one of which is really cool about this is that you can have your Aqua runtime protection solution feeding some of the informations that you would get from running those runtime security on your workloads. And it's also integrated with CloudWatch for sort of the more native approach to logging and monitoring, as well as managing your real-time container secrets injection with our Secrets Manager service. So that sort of illustrates a picture of not only what are you responsible for and what you should consider when you think about putting things into putting the shift right practice into place on AWS, but also how you do it, whether that's AWS native control or whether that's leveraging solutions such as Aqua and how that integrates back into AWS for you to have a more holistic view of everything that's going on. So with that said, I think it makes it a lot more intuitive and fruitful to see a demo. So that's, I think, where I'll pass off to Jake to show us how all of this really works on Aqua.
Yeah, thanks, Young. Let me just bring my screen up here and make sure that we can all see that. So when we're talking about shifting right and making sure that we have these security practices on that right side of where these workloads are now running, we need to be able to know exactly what kind of risks might be included in the applications that are running. So here, what we're looking at is in the Aqua platform, we have what we call our Risk Explorer, which is a great 10,000 foot overview of what your running workload looks right now. So I have an EKS cluster deployed here with a couple of workloads. And in this particular namespace, I have several pods. And you can see that based off the colors that were assigned here, that they have some issues that are running on top of them. And we want to be able to correlate into that to show you what those risks might be and allow you to be able to drill down into where those are actually running. So whether that be specifically about the workload itself, the image scan, whether that be from something that was in ECR or whether we discovered it as a workload that was running on your cluster, as well as the correlation into those infrastructure components as well. Now, when we're talking about the actual risks there, when we want to drill down into what those containers might be running, we can actually go down and be able to see all of those different containers here, where you can be able to filter them based off of whether they have security issues or whether they have are part of a specific scope. And then from there, you can be able to actually see all of those issues that are running through here. So the total number of vulnerabilities that are inside of a container that's running, or whether there was any misconfigurations inside of any Kubernetes assurance policies that we wanted to make sure that those Kubernetes applications or supporting resources are configured to be the most secure that they can be. As well as then those VMs here as well. So if you needed to go in to be able to see all of those different VMs to see the information that might be running inside of them or what issues might be involved there, we can be able to show you all of that information. But the real shift right approach here is when we're talking about the runtime policies that we can build. And we can make those for all of the types of workloads that you would be trying to run, whether that be your containers, your hosts, or even serverless if you're looking at those functions. Where when we have those controls, we're not just telling you about certain aspects of things going on inside of these containers or certain events. We want to be able to give you the ability to prevent those actions from being taken place altogether. So whether that be something like just being able to monitor any of the file system inside of a container or a host, whether that be monitoring for full command line arguments or network activity inside of those containers, or even prevent deployment of images that didn't meet our security requirements when we had set up our assurance policies, or even something that was never scanned by Aqua. So something that had no immutability behind it. We have no idea what kind of security issues are included there. We don't want to let those kinds of images get deployed. And then beyond that, with some of the other attacks that have come out and deployed recently, with our drift prevention capabilities that Steve had mentioned and touched on beforehand, we're preventing the change of any of the executables or any additional capabilities getting added to these containers while this image is running or while this containers is running, as well as being able to let you limit the attack surface and really shorten that impact crater to be able to prevent some bloat happening on images by being able to prevent or block specific executables from actually being able to run. Now, talking about this is great, but what's even better is me actually showing you in real time. So here I'm linked into my EKS cluster using Lens, which is an open source component or tool if you guys have never heard of it. But the first thing that I'm going to do is I'm going to try to create a resource from a particular YAML that I have here. And so when I'm trying to create this Kubernetes resource, we're going to get a response back from the console. So in this case, it didn't fail any of my assurance policies, and we had that one get created. Now, if I was to try to run just a quick script here to be able to actually see if this Kubernetes YAML in a different sense was going to be able to get deployed, we can see that this one is unregistered with the Aqua server. So I've never scanned this YAML. This isn't an image that I know what kind of issues might lie inside of it. So we didn't send that information to the Kubernetes API. We never tried to spin that workload up. So we're not trying to eat that additional CPU where Aqua is telling this workload it can't spin up and we're spinning it down. We just never sent the request in the first place. Now, that's great about getting those information to trying to deploy those workloads, but let's say I already have a running workload. And here, if I were to clear this up, I'm going to switch into my bin directory after I'm in this container as root, and I'm going to list out all of the commands that I should be able to run here. So this is everything that I have available for me to be able to run inside of this container. And if you remember, when I actually had this executables block list, I'm blocking my PS executable. So if I was to come back to this terminal and I tried to run PS, you can see that we'll get permission denied just like that. But the power of this tool isn't really shown with that one click right there. That is really shown from when I'm trying to update these policy. So let's say if I was to try to add /bin/date, and if let's say that, oops, that's not what I wanted. And before I do that, let me see if I can run that command here. And you can see I can get today's date back just fine. And now I know a simple example, but in the grand scheme of things, it's the same process. So if I was to save this policy, this restart required is for volumes blocked because they are mounted on container startup, but my executables aren't. So if I was to come back and try to actually now run date again, we'll get permission denied right off the bat without having to restart this container. Now, for an example of drift prevention, let's say I wanted to try to ping, let's call it aquasec.com. And so we'll get my response back from aquasec.com and we can try that. And now if I cleared that up, now in the list of my commands here, what if I was trying to add a new executable? And let's call it, I wanted to add an executable called Pong, so P-O-N-G. And you can see that's not in my list of things here. But if I wanted to copy, say, ping into Pong, and I can run the copy, I ran ping, and Pong is now a new executable that's there. So in theory, I should be able to do this, and just because I was changing the name of that executable. But Aqua knows that that wasn't one of my original executables in my image. And we don't want to make any configuration changes while this container is running because of that drift that it can cause and because of the potential of it being some kind of malicious activity or malicious executable that was getting dropped here, and not something as benign as me just changing the name of one of my existing executables. Now, with that, when we're talking about, say, some malware that we might have that is included here, when there's a certain file that gets added to your container, you might not actually know if it's going to be a malicious file until it's already too late. Well, Aqua now has the ability to do on-access malware protection. So if there was ever an incident where I had, say, logged into a container and I was going to try to download this malicious file, we can see that we're going to be able to get that. And now if I had this file located on this container, if I tried to actually go in and see that file, we can't open this file because it's not permitted. Now, because of that, when we actually go into our audit reports, and this is where that integration to Security Hub with Amazon will come into play. So we have our whole audit log, but you can also see the full event that came through when this actually took place. So when I tried to download this file, we see that there was a malware audit type, and we blocked that event from happening because we found a known malicious signature for that because of this malware protection for containers with that real-time malware protection control. And we do want to map those MITRE tactic and techniques to this event, so that way you know exactly what was happening and why we wanted to block that event, as well as any other relevant information that we can give you about the workload that this was affecting. And of course, that same thing is true for across all of the other events that I was just blocking. So when I tried to run that command, what policy that was taking place by which control, and of course, across all of these, even when I tried to do that deployment, when we blocked that, we can be able to see that there. Now, when we're looking at, say, the integration to Security Hub, we're going to see something more like this. Now, these are just a couple of screenshots that I have, but you can see through all of the findings that come through from Security Hub. If we had, say, something from Aqua Security that was getting forwarded to that, you would be able to see that this image scan revealed a certain number of vulnerabilities across that, and no malware, no sensitive data when we did a static analysis of that. But also in the runtime events, we see that we tried to access an unauthorized file or an unauthorized exec, so that way we'd be able to prevent that deployment, or be able to prevent that access to that particular resource. Now, the final piece here that I do want to touch upon is going to be that secrets management piece. So when we have an integration made to, say, a secret store, or whether that be a log management store, it could be the key management store, or it could be the secrets manager, we have the ability to actually inject these secrets directly to the containers that are using them because of our presence already there in that cluster. So let's say that there is this particular, when we have that access key and we have the integration made, you can be able to see that I can pull in those secrets, and these are all secrets from my secret manager here. So let's say that I had this one key called Jake key, or J key if you want to get technical here, and I need to be able to rotate this value. So this is a particular something that somebody leaks the password, or it's now my 90-day rotation period, and I need to make sure that this changes. So regardless of where this is being used, even if I had it inside of our manager here, you can actually see that I'm going to give you this password. It doesn't have access to anything, so there's no use in actually trying to do anything with this. But if I had gone and in Aqua made sure I needed to update this secret, we want to make sure that that value is synchronized across the board wherever it's being used. So in Aqua, in the container that it's actually being utilized, whether it be an image pull secret or some other kind of access, as well as then in the store itself. So if I wanted to change this password, and let's call it something like that. And so now I'm going to save the change to that password. And if I was to refresh my secrets manager page here, and as long as it doesn't log me out, if I see that new secret value, you can see I was able to update that right away and push it out to everywhere where that secret was being utilized. So if it's one workload, if it's 10 workloads, if it's one key store, if it's 5 key stores, it doesn't matter to us, as long as that we're making sure that those secrets are synchronized. Your applications can still use them and still be able to access the resources that they need to be able to. Right, so that's our shift right approach into the cloud native cycle of security. And with that, there is a lot of other breadth that we can be able to see across all of the different ecosystems that are out there. But I did want to take this time to be able to leave some time for being able to answer any Q&A if that was out there, whether that be from our chat here, or anything like that. So if you do have any questions, please feel free to include that into our Q&A. Or Steve, if you wanted to include anything on top of what I had just shown, please feel free to chime in here.
No, thanks, Jake. That's great. I think we did a good job of closing the loop between the importance of runtime protection, how runtime protection fits into the shared responsibility model, how AWS provides a set of tools that help operationalize runtime protection, as well as provide a feedback loop and a step into security operations for DevSecOps teams that are taking more responsibility for runtime protection and interfacing more with their counterparts in security operations. We did have one question, as Cody mentioned at the top of the presentation. Please feel free to enter questions into the Q&A chat. We do have a few, and the question was the utility of utilizing CIS benchmark configured systems and software. Jake, do you want Jake and Young, do you want to kind of take a crack at that question?
Yeah, absolutely. So the CIS benchmarks is exactly what they state. They're a benchmark. They're a great place to be able to start your security journey and make sure that you are in fact compliant with the industry standards and the things that we should make sure are configured in a certain way. But there's also a lot of need to be able to do things beyond that. So depending on what vertical that your company is in, whether that be financial, whether that be healthcare, you have other standards that you also need to be able to make sure you're compliant with or prove that you're compliant with. So the use of the benchmark configured systems gives you that nice baseline to be able to start, and then also additionally configure things in a certain way, whether that be for PCI, whether that be for HIPAA, whether that be for NIST, FedRAMP, or any of the other standards that are out there. It's a great place to be able to start and then build on top of that with tools like Aqua to be able to prove to whether you're going through an audit or prove to the security team that there is, in fact, something that we're checking for to make sure we are configured properly.
Yeah, and I think just to add to that, the reason that we integrated with the AWS management and governance lens is precisely that CIS benchmarks are already a solid starting point, but you also want to work off not just what is kind of the baseline set of security best practices to more prescriptive guidance, and as Yang was saying, also look at the access component. The kind of use of IAM roles is something that we integrate into our product at multiple, into our platform at multiple points, and there's also capabilities that we've built in for scoping role-based access control by application, which is pretty, as organizations move to kind of multi-account environments, that aspect of role-based access becomes more and more of an issue, because in the same way you can kind of look at techniques for container exploits to establish east-west traffic or north-south traffic. That role, if not configured tightly and not validated against some kind of prescriptive guidance or benchmark, can essentially achieve the same outcome where an attacker can gain access through that overly permissive role. Yang, anything from your end to add?
No, I think you both have well covered it. I mean, it's essentially called a benchmark. So obviously, think about running those benchmarks, and EKS provides its own curated CIS benchmark. Obviously, some of the CIS benchmark criteria doesn't apply here as AWS manages control plane and what comes with that. But just think of it as a benchmark, like Jake and Steve said. Just add on top of that to really hone in on your security practice.
Okay,
awesome. So we had one other.
Go ahead, sorry. No, I can't see it, so please go ahead, Jake.
Okay. All right. So we had one other question here. So how is the container scanned, and do we need to install an Aqua component within that container or some other way? So that's a great question. It's kind of a two-part or three-part answer. So I just want to make the distinction that we're not scanning containers when they run. We're monitoring the containers for any events that come through. But when we're talking about static vulnerabilities, we don't want to scan that static image while the container's running in that frame because it will cause overhead that we don't want to be able to eat CPU away from. We find the image reference from the container, scan the image statically, and then map that reference back to the workload that that image is based from. Now, when we're talking about the monitoring of those applications, which I think might be what your question was more frames towards, is yes, now we have several different types of enforcers, as we call them, which are additional applications that you would deploy into your cluster as, say, a daemon set. So that way, every node would get a enforcer and be able to act as the entry point for the rest of the applications. Now, that's on a standard Kubernetes or containerized environment, but there's also the need for other types. So whether that be containers as a service, where you don't have direct access to the node, we can be able to add our enforcer as a binary or run it as a sidecar. And in the serverless space, when you have a lot, pretty much bare bones of just some kind of function, in those Lambda applications or in those Lambda functions, we can be able to inject one of our enforcers as a layer to be able to give you that same monitoring and protection that we have across the board for any type of cloud native workload.
Yeah, and just to follow on from that again, if you kind of look at the the perspective of DevSecOps interfacing more security operations, one of the challenges with containers as a service, whether it's Fargate or function as a service, Lambda is you can be dealing with short-lived workloads. And if you're looking at understanding attack patterns, if you're looking to establish more threat models that are specific to cloud native architectures, it's really important to be able to monitor, capture those events in order to perform forensics and audit. So it is important to understand how those controls are embedded into the workload and how automated that process is in order to ensure that you do have the right level of visibility for that particular type of workload.
Great, thanks, Steve. And one final question here. It was, where is Aqua getting its signatures from malicious software from? So when we're talking about a static signature of a malware, when we're doing our static analysis, we have ClaimAV as our malware engine. But beyond that, we also have our research and development team, Team Nautilus, which has released several blog articles about some of the attacks that have happened recently. And they had a very good one about the Log4 shell issue that came out. But they're going out and they're finding these signatures themselves to be able to add them to our database. And that way we can be able to find these signatures and have some of the most accurate vulnerability and malware data out there on the market today. And with that, the signatures about the example I showed in the demo, those are just different signatures specifically about the capabilities coming from those particular files. So when we're looking for a certain kind of hash or a certain kind of capability from the file itself, when we do that scan coming from the enforcer that has these things preloaded inside of it, or coming from our cyber center, which is our cloud knowledge base of all of that vulnerability and malware data. So that way, that's where we're giving you all of that data from. And so beyond the static analysis, I can't give you a named answer or give you a noun about where it's coming from, other than our research and development team. They are doing a lot of work on the back end to be able to provide these signatures for our database and for the community that's out there to be able to find these issues and be able to make sure that there are no access to any kind of malicious files that way.
Yeah, and just to I don't want to preempt anything on your end, Young, and it's just something that you want to add, but just to kind of add, there's clearly as we see a growing prevalence of zero-day attacks, that there is a need to identify net new malware. and that's what we have been doing, as Jake was pointing out through our team Nautilus. That is a dedicated research team focused on cloud native threats. But as part of that, we've also released Tracy, which is an eBPF based open source project that is essentially, the mission there is to identify malware by looking at the eBPF traces, the kernel level visibility, and applying rules to first of all understand, is this something that's an indicator of compromise? What do we do that indicator of compromise? Can we fit it to a particular pattern, to a particular technique, and then enrich the cyber sensor database through that ongoing discovery and detection of new types of malware and attack techniques.
Great. I think that was all the questions. And so, Steve, I don't know if you wanted to touch upon this slide, but just to go over all of the different things that we're offering here at Aqua. If you have any interest in any of the things that we've talked about today, we have a large presence in that open source community. So like Tracy that Steve had just mentioned, we also have several other projects that are available on GitHub to be able to do things like native Kubernetes configuration checks, image scanning for vulnerabilities, that eBPF technologies looking for hidden behaviors, as well as cloud security posture management, and even some infrastructure as code scanning there, as well as where we actually can fit into the rest of the ecosystem in cloud native. And finally, thank you for listening to our webinar today, and I hope you guys enjoyed it. And Cody, I think that is back to you. You had some closing remarks?
I sure do. Thank you so much for putting together this presentation, that demo. I can tell that it was an engaging presentation for our audience as well, as we had a lot of good questions. So I would just like to first remind our audience that the on-demand version of this webinar will be made available shortly. You'll receive an email with a link to access it. And you'll also find it living on the DevOps website at devops.com/webinars, and just look in the on-demand section. So on to the 4 winners of our $25 Amazon gift card drawing. Our first winner is Hassan E. Our second winner is Tom H. Our third winner is Alessandro G. And our fourth winner is Arthur H. So congratulations to the 4 of you. Keep an eye on your inbox. And if you don't receive that email, check your spam folder. Jake, Steve, and Young, again, thank you so much for taking the time to be with us. I'd like to thank AWS and Aqua Security for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us for today's program. This is Cody J. Brown signing off. Have a great day, and please fill out our post-webinar survey, everyone.